Graham, good to see you again.
You too, there. I'm good.
I'm doing all right. We've got new tech set up here. I'm in the office today. Feels great. I'm out of my basement. I've got the mill here with me today. We're going to do some software demos. I'm going to pick up a bunch of Fusion Cam tricks from you, as I know are the handful of people that we have joining us. So yeah, if you missed the first part of this, 2 weeks ago, Graham walked us through CAD basics in Fusion 360 and talked a little bit about sort of some of the challenges of designing for CNC and things you have to keep in mind, internal radiuses, tool crashes, all kinds of interesting stuff. And today we're going to jump into CAM, and basically Graham's going to walk us through how to set up a part in Fusion and talk through a lot of toolpaths, and then we're going to take one of those, a couple of those operations, and I'll show you how to set it up in the Bantam Tools desktop CNC milling machine. And yeah, this is going to be fun. A reminder that we've got a chat on the right-hand side. I'll open this up. Drop your questions in there, and I'll do my best to interrupt Graham along the way and make sure that we all learn better for it. But Graham, take it away.
Sure, yeah, will do. I'll just pull things up.
Hey, Clay, Avi, Michael. Where's everyone joining us from today?
Okay, right, so there we go. Decided to work. Right, are you okay for me to crack on, Zach?
Yeah.
Awesome. So, yeah, thanks for coming, everybody. Obviously, as Zach mentioned, today we're going to be talking a little bit about CAM in Fusion 360 this week. I know there was a kind of a hot topic that a lot of people really wanted to get into the mix of last time around, so we're really going to sort of focus on the sort of key parts of CAM in Fusion 360, how we can set up some parts, and obviously Zach will talk a little bit more about how we can get those machined on a Bantam CNC. So just to start today, I'll give you a bit of a run through of what we'll be talking about. So we'll recap a little bit on how a part actually is programmed using a CAM software, and then how that would go through to a machine tool. Then we'll look at the Fusion 360 workflow, so what that looks like in Fusion. We'll look at the sort of toolpaths and strategies available in Fusion 360. We'll take a look at some of the machining parameters we as machinists need to take into consideration before we machine something. We don't want any breaking broken tools, that kind of thing. I'll jump into Fusion for a brief space of time and give you guys an overview of how to create toolpaths in Fusion, how to set up a part ready to go on a machine tool. We'll look at some machine configurations as well, a little bit about that machine tool, and we'll take some Q&A along the way as well.
Hey Graham, before we continue, one quick thing. I'm not sure if other people are seeing this, but the screen share appears to be a little bit zoomed in. I'm not sure if you're seeing that too, or if it's coming through. It could just be how I'm viewing things, but if it's clear for everybody, then we'll move forward.
Yes, before I move forward, let's see what everyone else sees, because for me it's normal, but we'll see how we do it for the time being.
Okay. I've got a couple extra video switchers plugged into my computer today, so let me just make sure. Zoomed in, too zoomed in.
Okay. I tell you what I will try and do.
Maybe quit the screen share for a second, yeah, and reboot.
Yeah. And then I'll try and, let's try. Is that still zoomed in?
Still zoomed in.
Okay. Let me try, let's see, one thing I would switch. Here. Let's see if I can.
While Graham is troubleshooting this, anyone who is joining today and is hoping to pick something up from Graham, from like what are people interested in learning today, so make sure that we touch on it. We're going to be talking about all the different types of toolpaths. We're going to be talking about how to post code, the general workflow. And I'll also go through the material probing routines. Mine helps, says Michael.
So let's see. Let's come through on a different screen now. Hang on. I'm not sure why this is. Try this. Right, is this zoomed in?
Still the same thing. What about if we split the difference and you just go from scanner says two-sided machining? That's what we're going to talk about. Yeah, it's kind of working great until you get the slideshow. What about if we just go from the non-presented view?
Yeah, so I'm not actually using presenter view, but is this what you mean,
like this? Yeah.
You see this, all right?
I think that this is probably good to keep it moving.
Yeah, absolutely.
As long as that's okay. Cool. We're getting some thumbs up on this idea. Let's move forward with this.
Yeah, absolutely. I'll just move my mouth a bit closer here. Perfect. Right.
Couple questions that came in. People want to know how to design for fixturing, how to design for multi-sided operations, the process of taking Fusion 360 design and getting it into the machine. I think we're going to cover all of these things right now. So Graham, dive in.
Yeah, absolutely. So just as a little bit of a recap, obviously last week on obviously how a part is programmed and what the steps we need to take through. So obviously from last week we did a bit of CAD. So obviously we've got our CAD model, and what we need to do is we need to identify our stock material. So that's the raw bit of material we're actually going to subtract material from to create our parts. We're going to create what's called a setup, identifying work coordinate system, basically the machine tool can use as a reference. Then we're going to pick the tools, look at machining parameters which are appropriate for the job. We're going to create some toolpaths, we'll simulate it to make sure it's safe, we'll export our INC code, and then that code is used to be machined on the machine tool. So how does this look like in Fusion? So in Fusion, again, we have our part that we've imported here or we've created ourselves, and then we define the job setup. So you can see this sort of yellowy ghosted box here. That's our stock material. So as we would say, have a part in a machine tool, that part that's held, we're going to remove material from, that's our stock. And this 3-point coordinate system here, a work coordinate system, that's the positional reference that our machine tool is going to use to basically know exactly where our part's going to be. So I believe on our part later on, it'll be identified on the top left corner here. So once we've identified essentially what our material size is and where it's located in the machine tool, then what we do is define our operations. So whether that's any one of these kind of 5 aspects of machining or a subset of what those are, so whether it's roughing, to remove as much material as we can, as quickly as we can, so that we can get on to finishing, where we basically just take the thin bit of material that's left after roughing, machine it a little bit slower to get that high quality finish and make sure there's a bit of tolerance, so that when we finish our component, it's going to look nice and sparkly and do exactly the job we would like it to. But the main thing to point out really with Fusion, with defining operation, the nice thing is on the left-hand side here, you've got these 5 tabs. The nice thing about Fusion, especially from a learning point of view, is you don't need to know what every single toolpath does. The properties box won't be different for every single one. The nice thing about Fusion is it's only 5 simple steps to go through to program a toolpath, and most of the time you don't even need to use all of those. So that's one of the really great things about Fusion. I'll touch on that once we're actually in the software. So we can simulate a toolpath, again, to make sure there's no collisions or gouges. If there are any, we can see that it is a red node. We can file and amend those if we need to. But if
I just lost audio. Hey, Graham, if you can hear me, your audio just dropped out. I think that the mute just got turned on. If you can unmute yourself.
Oh, that was strange. Can you hear me now?
Yep, we can hear you now.
Which point was that did I become muted on?
Go back 2 slides.
2 slides to simulation.
Simulation.
Perfect. So just a quick recap. For simulation, all we're making sure that we're doing is making sure there's no collisions or gouges, and it's nice and safe to be able to run the actual job we want without any tool breakages or collisions, that kind of thing. And they just a quick point to point out these red markings at the bottom here. As you play the simulation, those will denote if there are any collisions or gouges, and your whole tool will glow red. So it's very hard in Fusion to miss a collision or a gouge. So that way we know that when we go into our job, we can see, okay, this is nice and safe for us, so we can carry on. So our NC code is essentially, we take this toolpath information from Fusion, and we translate it using what's called a post-processor. So the post-processor takes the information from Fusion, translates it into what's called NC code. And this NC code, I won't go too much into this, but how we can figure what it is it will be separated into a certain type. So this could be, say, if it's G code, it will be motion. So let's say if it was a G00, that would be a rapid move from one cutting area to another. Let's say if it was an MO6 tool change, it's a miscellaneous function. You're going to get the idea. So if it's an MO5, MO4, F, 1000, these all have a letter and then a number to denote what those are. But don't worry, the nice thing about using CAM software is we don't really need to know what these are. If there's a very complex problem, we might need to, but it's extremely rare for us to need to know what the NC code is itself. So look at the setup and strategies within Fusion. So I talked before about how you need to create a setup and identify the stock. So what we'll do is, say if we had a part like this Fusion F here, what we do is essentially we create a setup, and Fusion automatically knows the size of the part. So it will usually create what's called a relative size box, dependent on the size of this component. We can then change this if we would like to, and I'll show you this more later on. But essentially, you can see these little dots here. Most of the time, we would pick a certain corner or a certain aspect of the stock itself to identify a work coordinate system. So like I was saying earlier, so we know exactly where, the machine tool knows exactly where the part's going to be on our machine bed. So next up, these 5 categories here are all 5 tabs I was talking about in Fusion. And I know what you're thinking. You look at this and you think, wow, that's a lot of dialog boxes, a lot of tick boxes. But really, the thing to note here is you don't need most of these. Okay, these are for obviously maximum customization, but really most of what you need here is very little information. I'll show you this in Fusion. So whilst when you can open Fusion, you might think this looks really daunting, looks like there's information. A lot of this is either calculated for you or is based off tool data and default settings, that kind of thing. So trust me, you don't need to put this in. So yeah, just a bit of a sort of, can be a bit daunting, but these 5 tabs are the main tabs that we need to look at, and I'll talk more about these as we go through. So in the geometry tab, most of the time we have to select what's called a boundary. And a boundary basically denotes which aspect of the part that we're going to be machining. So in this case, in the top right here, you can see you've got a start point here, and it winds round, and an end point. This is what's called an open boundary, with a start and a finish. When it's a closed boundary, it'll be like this icon here, and then what you can see in the bottom right. So you can see what's in the bottom right here. As it loops around, it has no start or finish. So in this case, we want to select all this area here. In this case, in Fusion, we've selected just this fillet. We want to select this part as well here. So within Fusion, if the video doesn't seem to be playing this video, that's fine. I'll show you the more from the software, so I'll get to that later on, actually. That's fine. So the next up is the Heights tab. So within the Heights tab, basically, the main thing to take away from this, again, looks like lots of dialog boxes. The main thing to take away is this essentially is the heights in which certain aspects of machining take place. So the main 2 really we need to think about are the top and the bottom heights, so the light blue and the dark blue. As you can see, light blue, dark blue. So basically the top of this cavity and the bottom of this cavity. Everything between those two lines are where our machining is going to take place, where our actual machining is going to take place. Above that, we have our... Yep, Zach, is everything okay?
Yeah, no, I was just going to say, yeah, those 2 are really important. That's where, like, a lot of crashes and bad things can happen when you get those wrong.
Yeah, absolutely. Or even you set them too high, you think, why is it not machining?
Sure.
Any
and it's
yeah.
cutting air. Yeah, exactly. Right.
Absolutely, yeah. And above that is our retract height is essentially once our material, say it's say 2 pockets, our tool might be machining down here, it'll retract up to this height, safely navigate itself across and go back down. So that's the maximum height that it will go to make sure it's actually clear of the top of the stock so we can move safely. The feed height is the height that the tool is going to spin at full speed as it's approaching the part, and the clearance height is the height where basically the tool knows it can move around safely. So none of the fixturing, anything else in the machine tool is going to get in the way. If I'm navigating at this height, that's our actual safe height.
And Graham, just so we can weigh in there, most of those things are set by default, but like in facing, it's set usually from the top of the stock to the top of your model, and you would have to adjust away from that. Like there is some, you're not always adjusting all of those, the number from the heights tab. Yeah.
Yeah, that's what I was trying to say on the CAM properties page. You say sometimes it looks like you have to do everything, here, there, and there, but trust me, you don't. And like you say, the top stock default, so the top height default is always the top of the stock for safety reasons. So I'll get more into that into the demo.
Great.
So a nice nifty tool as well is something called rest machining. So what rest machining is essentially is if you can see this part here, you can see this half pipe here. We mentioned before about how we want to rough out and get rid of that material as quickly as possible. So to do that, we might want to use a really big tool. And it's great, it'll remove that material really quickly. The problem is it'll leave these sort of steps in the material, these large steps. So it's not quite enough to finish the part. So using rest machining, we can use a smaller tool and we can identify essentially just the material that's remaining, hence the rest of the material, if that makes sense. And by doing that, we won't machine, we won't perform any air machining in the middle here. We'll just focus on the steps that are remaining, cut those out, and do what we call semi-finish. And then from that, we can then take a finishing tool and then finish the part itself to make sure it's nice and clean and not put loads of stress on the tool. And again, I'll show you examples more of these as we get through these into the demonstration. So I'll give you a sort of nice overview of 2D strategies in Fusion and what these might look like. And the main ones really to take away are the pocket and the adaptive clearing toolpaths. So with the pocket toolpaths, what you get is you're going to get an offset from the pocket here inwards. So you get a nice consistent surface finish. But with the adaptive instead, what you'll actually get is more of a kind of a spiral which chips away at the material itself. And on the next slide here, these were meant to be guessed, but I won't be able to show them because of the zooming in problem. What you might be able to see here from the graphics below is with a traditional pocket, the pockets are more ideal for if you're cutting, say, with the bottom of the flute. So you'll get this nice consistent offset pattern. However, you're only really utilizing this much of the flute length. The nice thing about adaptive pocket is we can go a lot deeper. Instead of doing, say, multiple depths one at a time, which takes a lot longer, we can use more of our flute length, cut deeper. So you can see here that the step over here is a lot smaller. However, we utilize all of this flute length here. And that means more of an optimal load on the tool. So it reduces tool wear, so you get more life out of your tool. And also it means you're going to put less stress on the tool itself. You get a bit less deflection as well. So yeah, so it's more of an ideal strategy if you're going to be removing lots of material. So just giving you an overview of some 3D strategies here as well. So the 2Ds are the kind of flat surfaces you see, the very simple kind of flat surfaces. And the 3D, you can see we're looking more at this kind of free-form 3D geometry. And we can use adaptive clearing and pocket clearing in 3D as well. But obviously, if you can see here, most of the 3D strategies that you might end up using will be finishing strategies. And just to point one out here, horizontal is probably your best friend in terms of a machining toolpath. And I'll show you this in the demo as to why that's the case. Here you can see Fusion in 2D and 3D has got a really wide range of methods for manufacturing and using certain toolpaths.
And the one thing to call out about 3D toolpaths too, right, is that they're model aware, whereas 2D toolpaths are not necessarily model aware and requires the user to select the geometry that you want to utilize that toolpath for. Whereas like 3D adaptive clear, you could basically turn it on and
you can press OK and let it go. Yeah, that's one of the nice things about Fusion. So yeah, absolutely, great point. So all of your tools are stored in what's called the tool library. So in this, we can basically categorize tools and locate tools really quickly and easily to make sure that, obviously, from our point of view, if we've got a huge library of tools, we can categorize and basically find the tools we want very quickly and easily. But not only that, and this is especially useful for beginners, is that we can use what we call these default presets. So let's say if I was machining aluminium and I wanted to rough out something, I could use my aluminium roughing preset to know all my feed, speed, and tool information would be for aluminium roughing. If I then wanted to do finishing on the aluminium afterwards, I could then select the default preset for aluminium finishing, and hey presto, I've got all that information straight away. The more experienced users will maybe tweak these a little bit, but for beginners, having this information in Fusion is absolutely, it's absolutely incredible. It's really, really vital, because it just means that from our perspective, all we're focusing more and more is obviously machining the part and making it, and not worrying too much about the kind of the toolpath data, which can often be, for beginners especially, something which takes a while to get your head around.
Yeah.
So that tool information, I'll go into a little bit here in the machining parameters. I'll explain a little bit what you have to consider. So there's two main areas of what we have to consider when we're machining something. That's called step over and step down. So step down is essentially the distance between machining pass, between certain Z levels of machining passes. So if I cut, say, at this level, and then I cut at this level here, the distance between that is what's called the step down. So if you have too large a step down, it can increase tool wear, and obviously this should not surpass the flute length. So our flute length up to here, if we had a step down above here, we're entering a territory where we can't actually cut with that section of the tool. So we have to be wary with this. The step over is the distance between each machining pass. This is in X and Y as opposed to Z. So with a flat bottom tool, we can use quite a large step over. Give it a nice 2D surfaces. Really, we can use a really big step over, and that clears the tool as it clears the material quite quickly and easily. What we need to think about is round bottom tools like the ball nose here, because the bigger the step over, the higher the cusps we're going to get on these as well. Now, you're always going to get some kind of cusps. We can't eliminate them completely unless we have a really small step over. So if you've got 3D geometry, don't worry sometimes if when you look on the software, you say, oh, I might have a little bit of cusps. Don't worry. In reality, when you're gliding your finger over it, most of the time it can feel very smooth. So obviously, it's more about contemplating what would be a sensible step over, as opposed to something which is going to make the machining time, into the hours territory, and we definitely don't want that. So the feeds and speeds are the information we were talking about in these sort of presets, and what we need to think about when we're machining. So the first important thing is what's called the feed rate. So that's how fast the tool travels. So this is usually measured in inches per minute. The spindle speed is the speed at which the tool turns, so obviously that's revolutions per minute. And the nice thing is when you purchase tools, you usually get these kind of data tables with them. And it means, again, from a beginner's point of view, if you can say I'm using an end mill on some aluminium again, I can see here, these are the feed per tooth height that I'm going to get, the information I'm going to get. So if I need to be really specific, I can type that in, and that information is provided for me. So always look out for those tables if needed. If we're looking for the best surface finish, so obviously when we're doing our finishing passes, we want to run like a moderate feed rate and a high spindle speed. That's going to make sure obviously the tool's moving a little bit slower, so it's got time to revolve around the material, so it's going to clear away that, create a nice smooth finish. So obviously if we're roughing, we want a good removal rate, we want a fast feed rate and a high spindle speed. We want to get that material out there as quick as possible so that we can focus on the finishing. Where we need to watch out, and you can see from this image on the right, where we can lead to tool breakages, is if the feed rate is too high, essentially it can't cope. It's too much, generates a lot of heat, and the tool can break. The same with the spindle speed. Again, if that tool's rotating too quickly, we can get the tool overheating, which doesn't always break the tool, but it can actually blunt the tool a lot more quickly, and even melt the material as well. And trust me, you don't want to have to fish out an end mill from some melted material which is cooled down. It's not a fun process. So I'm going to jump quickly into Fusion 360 now. So if I just use the screen share for Fusion, I'll show you a little bit about Fusion and how we can program some CAM toolpaths. So here we have this nice knotting tool we use to hold some ropes.
Yep.
And what we're going to do is we're going to basically really quickly create some toolpaths. And what I'm going to show you here isn't programming every single facet of this part, but I'm going to show you how quick and easy it can be in Fusion 360 to create the toolpaths here. So the first thing we want to do is create that setup I mentioned before, this top left icon here. And then the first thing I want to do is make sure basically that my stock is going to be the right size and my work coordinate system is pointing the correct way. So I want my tool to be traveling in Z. So I want my Z to be pointing up this way. So to do this, I want to orientate it. I want to make sure to orientate it, I can select the Z axis. So this is going to be perpendicular to the surface here. So you can see that my Z axis is now pointing upwards. I can define my X axis if I would like to, although it's pointing this way. But just to be sure, I'll select this edge here. And you can see that my X axis is now parallel to this axis here. If I want to flip these, I can simply click these here and it'll flip that very quickly and easily. So again, very easy to customize and do very simply as well. So now to the size of my stock. Fusion is going to give me a relative size box in this case. So it's going to say, here's certain offsets from this model. However, if I've already bought my stock, I know what size it is. So I'm going to use what's called a fixed size box. So this I'm going to use, say, 3.5 inches here, 1 inch here, and then my height, I'm just going to make sure that is 0.75. And you can see it's going to center all of these, my model in between all of these axes. So you can see here my model is very central in this. But let's say I want to make sure that this is a little bit closer to the surface. I don't want it to be central. I could say, here's my model position, my offset from the top. That can be 0.95. So you can see here now I've shifted this more to the top, so I've got more material on the bottom here to grab onto. So I think we had a question earlier about designing for fixturing and actually how you would hold that part. The great thing about having enough material like this here is we've got lots of material to grab onto. If we've got like a thick, say if we were grabbing onto this part here, and there's a very thin part that we're going to machine, obviously that's not much for the machine tool to hold. So as we're generating forces on that, there's more chance it's going to move it in the fixture or even pop out because there's not as much to grab onto. So that's the first thing we want to do.
Right.
So we've got
and on my camera, if you can see this, we've got this piece of stock set up in the machine too, just so you can kind of follow along visually with what Graham's describing.
Awesome. So the first thing obviously I'm going to do is create what's called a facing toolpath. And like 99% of the time, this is the first operation that we're going to create in Fusion 360. So I'm going to show you quickly just how quickly you can actually use create a toolpath in Fusion. So up here, we've got our 2D toolpaths, and here's the little list of them here. If I select face, so the first thing I'm going to do is going to face this top part here. So I've selected my facing operation, and I'm just going to press OK.
Hey, Graham, one thing just while we're going, would you mind actually going back into setup? Because there's just something that's important, and I'll go over this too. But could you select the front left corner of your stock rather than the center of the box point?
Absolutely. Yeah, so instead of the center, I can go to stop point here. And instead of selecting the central point where it says box point, I can actually select this top left corner here. Because a lot of the times, this basically gives us an ideal reference because we can then say, I can tell what my x-axis is, my y-axis, my z-axis is. The problem with using it in the center sometimes, it's very hard to identify where that location can be. So obviously by having it in the corner, we can identify it a lot easier. Thanks for the reminder, Zach.
Yeah, no problem. Thank you.
So just in case you guys missed that, I guess it's just that facing toolpath. I'll just quickly delete that and then just do that again. So to create a facing toolpath in Fusion, it can be as easy as this. So if I just go facing toolpath, OK, done. Now, it would be great if we could do this for every toolpath. However, obviously that's not always the case. But in this case, you can see how quickly the default settings in Fusion are very good to the point where we know that if we do this, that Fusion is going to intelligently know, I know most of the time what the user is most likely going to use and what it would like to do. So you can see here, a facing toolpath is level with the top here, and it's cutting exactly what I'd like it to cut. So again, you can't do this every toolpath, but obviously for some of them, if your default settings are good enough, you can. So if I just...
Quick question that I think is a good one to explain. So Frank is asking, is there a tool to measure the amount of stock you plan for the stick out of the vise? And Frank, we go over this a little bit in the video that we put out on this project. But if I'm understanding you correctly, I think that what you're asking is, hey, in Fusion, if I'm in this cam setup mode, how do I know kind of where to align the model? how much stock should I leave below the model in order for it to stick up out of the vise? Graham, is that making sense to you as I pose that question?
Yeah, I think there's two things here. One, I think that comes with a little bit of experience. So again, it's so the amount I showed you before, it's better to be safe than sorry as you're starting up. There's no kind of golden rule for this, unfortunately.
Right.
But the other thing is look at how you're holding your parts. Whatever contraption you're using to, whether it's a fixture or a vise, whatever that might be, look at just a maximum depth that you can hold in there, because you can go overkill, but you can also go underkill, and it's better to be safe than sorry. So I'd say as time goes on, just there's no kind of golden rule, but it's to give yourself enough. And it's always hard to say because there's no direct measurement, but you can see here I've left enough material. It's that way. It's more I at least know if I've left this much material here, I'm very confident that the height of this is about just a little lower, that it will definitely be enough to hold that. So yeah, it definitely comes with experience, but it comes more with how tight you hold it. As long as you hold it tight, most of the time it should be fine.
Yep.
So the next part I'm going to do is, so obviously I face off this top bit, and obviously I went through that very quickly. So the next operation I'm going to use is a 2D adaptive. So I'm going to do a 2D adaptive clearing here. I can take a little bit more time with this, and I'll show you basically what these five tabs are. So the first tab here is the tool tab, where I select my tool. So in this case, if I press select, I'll open my huge tool library of all these different tools here. And it's nice with this because you can categorize and basically narrow down what tools are available. So if I we go into this one here, let's say this is the tool library I have just for this document, and it is. These are the tools I have available. But this could be really big. It could be I have lots of tools at my disposal. I can actually sort these into certain categories. So if I was going to be using milling, which is what I will be doing, I can go to milling here. But I say I want a flat end mill, I can tick this as well. And you can see as soon as I start to tick these, more of these start to disappear. And I can specify these more by diameter, and I can use lots of different ranges and values to specify this. And so as you can see, there's lots of different ways. If you have a large list of tools, if you say, this is the exact tool I need, I'm going to search for it, you can do that using the filters as well. And you can untick these, and they'll start to pop back up as well. So in this case, I can select my tool here, a 1/4 inch end mill, and I can go to the geometry tab. With my pocket selections, I'm going to select this edge here. And you can see what it's done is it's given this this ghosted blue outline here. So you can see this ghosted blue. What that means is it's going to machine into these blue areas here. And that's denoted by this red arrow. So if I press this red arrow here, it will actually machine inside this part. Because what it sees is the boundary. Obviously we don't want this, so we just want to make sure it's in the right place. However, this is not the depth of our toolpath. So as I mentioned before, the heights tab, what you really want to do is make sure that we have everything at the correct height. So in this case here, where we have the top heights we mentioned before, the top height will always default to the stock top. So if I see this here, that is the height of our stock on the top of this. So we have removed the top of our stock in this case, so we can say make this the model top if we like, don't have to. But the nice thing is Fusion will always default to the selected contour, because it'll assume most of the time, say if you're machining the bottom of a pocket, that's the very bottom surface we're going to machine to. However, in this case, because we've got this radius underneath, we're not going to do that. So instead, I'm going to choose selection. I'm going to select this bottom surface here. So that is now level with this bottom surface that I'm going to machine. So that means my machine tool is going to go down to the very bottom of this surface here. However, because obviously there's always slight bits of inaccuracies, and we don't really want to be machining that close to the face here, we want to give ourselves a little bit extra. So what we'll do is we'll add an additional offset here, say of 0.5. Oops, sorry, 0.05. Press OK, and you can see here it's created our adaptive clearing pattern here. Now, the main problem we've got is this tool can't actually access these areas. It's too big. So how do we get through that? And how do we do it quickly as well? So instead of creating a new operation and going through the whole palaver over and over again and specify, say if we'd specified lots of different things in all these different tabs, okay? Instead of doing that, what I can do is click this adaptive, right-click it here, then go down to duplicate. So essentially what I've done is created a toolpath which is exactly the same. So all the settings are exactly the same. I'll open this by double-clicking it, and I'll select a smaller tool, like so. So this is my 16-inch end mill. Might be a bit too small. Let's see if there's a different one. 8, there we go. 8 should get in there. And then we can take rest machining like we showed before. So, so from the previous tool, I think that was an 1/8 end mill as well, wasn't it? I think was it 8? Was it 1/4 inch? I think it was.
I think you had 1/4 inch in there. Yep.
Yes, 1/4 inch. Yeah. So press OK. So you can see it's only getting in machining the parts we would like it to machine. So you can see we're not doing any air machining here. It's only focusing on the remaining material. And you can see again if we would swap that 16th that we used before. I'm sorry, I didn't change the. Yeah. So no, it was. I kept it before. Sorry, I'm getting. It was 0.25. 0.25. So yeah, I could have left that as it was. And you can see here now how it's doing these parts here because it's a smaller tool. So you can see it's getting in there. It's just clearing out those areas which obviously that tool previously couldn't get into. It's a nice sort of a quick tip to see how it's getting in there and machining those without air machining as well. So you can see even if I open one of these here, that we touch on the heights tab, the passes tab. If we'd like to, we could specify our step over. In this case, what's called an optimal load, because in this, with an adaptive, it's not a constant step over. But essentially, this is the optimal load. If I hover over this here, you can see is the kind of maximum gap that's going to be between each clearing pass. So let's say if I wanted this to be 0.2. So I could press OK. However, for future reference, if I always wanted it to be 0.2, I could hover over this, right-click, and press Make Default. That way, it means every single time I open this operation and press OK, it'll give me exactly what I would want to see, which is that 0.02. And this is a really good tip and trick in terms of if you have certain ways you like doing things, it doesn't just apply to optimal load, it applies to other parameters as well. If I make that my default, I know that's that tip and trick I used before, the facing operation, where I just press facing and OK, we're more likely to be able to use Fusion using that kind of method. And the other thing here where we've got, say, stock to leave, this is the remaining material we've got, say, on the sides here, in the radial stock, or on the axial stock, obviously on the top of these flat surfaces as well. So if I left stock to leave on the facing operation here of 0.04 inches, that would have left 0.04 on the top for us just to clear away. So because these are roughing passes, we want to be able to make sure that we can leave some stock on here to be finished. But again, if I wanted to change these, I could right-click and make the default, or I can even go to Edit Expression, and I can type in a formula here based on the tool size as well. And when I press OK, if I use a formula there, it'll be applied in the same way that Make Default will be applied as well. So if I want to go back, I can right-click and press Reset to build-in default, and that'll take me back to the defaults in Fusion.
And I just want to repeat that one bit because I think this is important to understand. So far, we've built up sort of two. I'll just classify them as two things. We're facing down to the top of our model, and then we're using these adaptive paths to rough out the general shape. And what Graham is saying right now is because these are roughing toolpaths, they're not going to leave like perfectly clean edges, right?
Yeah.
And so we're making this decision to leave some stock on the side of the model. We could leave it on the bottom or the top of the model too if we chose axial. Because Graham is next going to program in a toolpath that's going to come around and clean up the walls of this part, and that's going to be a contour toolpath. So just that's a really important thing to keep in mind as you become more experienced in Fusion. You'll want to check that stock to leave box. I know as a beginner, like when I first started, I definitely was not using that. I would just machine out the whole model and call it good. Call it good with the one toolpath because that was my comfort level, but.
Yeah, and it's easy to do, yeah. So as Zach mentioned, we can do a contour. But again, because we're using this edge here, so we're going to clear the walls, but we're going to use the same edge. So what I can actually do is I can go here, right-click, and instead I can go to Create Derived Toolpath. So basically what I'm doing is I'm taking the information from that previous toolpath and just applying it to a different one. So see, I've got my same tool. So again, this time I can select a different tool, like so, to make sure I can clean that. But you can see here, because I've used Derived Toolpath, it's kept this edge here. So it's nice and quick and easy, but most importantly, it's kept this bottom edge here. So I know that that 2D contour, which is going to come clear up these edges, and like Zach said, finish off those edges. I now know that that's going to go to the same height as my previous operation. So as you can see, as I'm going through this, I'm essentially I'm helping automate the toolpath creation process. So you can press OK there, and you can see I've got a nice, simple 2D contour, which you can clean up these edges. And if I wanted to, because I remember we said before, if you have too big a step down, that can put a lot of stress on the tool, I can go to my passes tab. We haven't really touched on this too much yet. I can go to the multiple depths tab, and I can say, okay, if I want, a certain number of step downs, I can apply more finishing step downs on top of that kind of thing. But the one you want to focus on more is the maximum roughing step downs. So if I say here, 6.
And while you're doing this, Caesar is also saying, hey, are you guys doing full depth of cut on the sides? And would we do this on this Bantam Tools desktop CNC milling machine? For roughing, we would do multiple depths, just to like rattle off some quick numbers. Right now we're finding like a nice balance, certainly with the single flute tools, of doing more of a width of cut priority. So we're doing like something like close to 60 or 70% width of the tool, and then a shallower step down. And the machine seems to really like that for roughing, certainly with single flute tools. But for contours, we're going to go full depth of cut to preserve, the finish on the wall. So Caesar, hopefully that helps clear that up for you. Sorry, Graham.
No, sorry, absolutely. So the final thing I'm going to do, because I think we're a bit pressed for time, is just show you a 3D toolpath. So in this case, I'm going to show you a scallop, which is going to cover these fillets here. So again, the nice thing is we jump from 2D to 3D, and you can still see these 5 tabs. Again, it's a similar process. It's something that, again, once you learn how to do it once, you'll know how to do it for all of them, which is a really great thing about Fusion. So we can select, this time, our ball end mill. So you can see they've got this sort of hemispherical, we can make sure that we can machine these fillets here. And this time what I'm going to do is I'm going to select 2 boundaries like so. So on that previous slide, you saw that I had the light green. You can see I selected the light green, which by clicking on it, it'll automatically map a boundary. If I wanted to edit a boundary, I can click once, single click, and I can select an area like this, press plus, and it'll accept just that boundary here. And click again and delete that if I want to as well. Again, so as you can see, it's just click and edit, really quick and easy if Fusion doesn't quite give you the boundary you'd like. So in this case, what I'm doing is I'm basically saying I want to machine between these two boundaries. But because of the shape of my tool, I've got a sort of hemispherical shape of my tool. The bottom middle, so the center of the tool, the bottom is going to weigh what my reference is. So if the bottom center of my tool is here, it needs to go past this edge. Okay. So to make sure it does that, I'm going to need to make sure I use what's called contact point boundary. So hover over this here, it'll show you a quick graphic. You can see if I enable that, it allows, even though I've specified the same boundary, it allows the tool to go past that to make sure that we don't get those sort of hard steps on those corners. So it means the tool can flow past that and we get that nice smooth transition of the machining. So if I tick that there, it'll make sure it won't go past that point. So I'm just going to show you something quickly if I press OK without doing anything else. Okay. So you can see here, I've got this toolpath, but remember what we said about the cusps before? That's going to give us really bad cusps, and that's not what we want. We want to have nice, smooth toolpath. So we can go to step over, we can reduce it by a lot. You might have to forgive my knowledge of imperial measurement system. This might be completely wrong. But yeah, so you can see here a much better toolpath in terms of what's going to give us a smooth finish. You can see it's also steeping quite far down, a little bit further down than we would probably like to. So what we can do is go to heights and select a bottom height here. Select this, so you don't go anywhere past here, and that'll limit it a lot more. So the contact boundary is still in place. So if you look from the side, it still is technically going past and giving us that, obviously making sure that it's giving us that smooth transition. But obviously, because we haven't specified the height, we're adding a lot of machining time onto there for no good reason. So that's, yeah, always a useful tip. So if I just quickly jump to the kind of, here's what I did earlier on my toolpath here. You can see we've got a whole operation sort of a single setup here. Again, similar practice with our setup in the top left. There, with our adaptives, a boring operation to kind of cut this part out of here. Horizontal toolpath, which essentially just cuts lots of flat surfaces to tolerance. It's a finishing toolpath, can be used as roughing, but it's a great toolpath because most of the time, like a facing operation, you can just press horizontal, OK, it'll machine all the flat surfaces. So down to our scallop. And then we've also got our op2, where it's on the other side. You can see our Z is pointing upwards here. So you can see on our op2, you can see it's exactly the same. However, you can see that I've got this from a solid stock, and to do that, we look in the simulation. We go to the simulation. So let's say I want to just simulate op1. I select op1 here, go to simulate. If I show my stock here, I can press play. So like so, and I can watch it go. So I can change it to material, so I can see the toolpath a lot more easily. So you can see what's going on here. If I want to focus on my stock, I can turn my toolpath off to see exactly what's going on here, not look at the toolpath. If I want to see less of my toolpath, I can use what's called tail. So this is like Snake. So if I slow it down, you know, like the mobile game Snake. You can see here how it's going like this and disappearing at the end. So it's nice that it means if we pause it, we've got this nice and manageable part of the toolpath. So if I really want to have a look at these parts of the toolpath, I can look at that without lots of cloud, you know, of what's going on here. Yeah, so it's nice and manageable.
I love that.
Yeah.
Just put your old Nokias aside and let's just get into playing this Fusion simulation instead.
Exactly. So then, and one of the best tools though is what's called comparison. So if I skip to the end of this here, so this it'll just take a little bit to loading up because it's just skipping to the end of the toolpath. This is kind of what our first op from what we've done so far. So if I go to comparison, you can see here all that's in green is within tolerance. Everything that's blue is material, is excess material that needs to be removed. If you saw any red, that basically means that we've removed too much. Yeah, so that we need to modify something. But you can see here that's the bottom of this part here. That's what we need to remove. We know that anyway because that's our bottom operation. But what we can do is we can right click and we can go to stock and we can save the stock. Okay, so basically what we're doing is we're saving this as we've simulated here. We can save that stock. Close that. So then what we would do is we'd go into the design workspace and we would insert a mesh because the stock will be a mesh like so. So this is what that mesh is here. Let's hide that. So that's what my simulation looked like. So yeah, it looks a bit jazzy because of all the triangles in the mesh. And I can jump back to the manufacturing workspace here. So with that inserted, I can go to my op2, and instead of saying relative size box, a fixed size box, I use from solid. And I've just chosen the solid. So again, we're reducing the amount of air machine cutting we're using, having an accurate, we have an accurate description of what we machined so far. So we can press OK, and we can start to create more of these toolpaths, like so. And we can finish off, obviously, our part. So if we were going to simulate the whole thing, I can click on all my setups here, simulate, skip to the end, just give it a little bit of time to skip through these toolpaths, and we should hopefully see a sea of green, like so. So it's still going, just a little bit more. But yeah, so as you can see, we've managed to do it from both sides. And again, the process, even though it's flipped on the other side, it's just as easy, just very easy to get all the toolpaths out. And we have our parts all nice and green, which is great. And if we post, we can go to post process, and we can come to our post dialog box, which will just scan my computer for the current post we have available. And then we can take our information, so we can scroll down, I think it's other mill one here for Bantam, and we could specify different values. So I won't go into this too much. This is more for sort of moderate to experienced users. So we can make certain changes if you would like to. All those changes appear in blue, and we can press post, and that will generate us some code. Okay.
Cool.
I'll stop sharing from there because I think we're a little press a little bit of time. So
No problem.
I hope that answered a few questions for Fusion wise. Anyway,
Graham, that was so awesome. I'm over here, but that was terrific. I wish that I had, like I said before, I wish that I had that stuff when I first started. I think what we'll do now for these last 10 minutes here is jump into sort of the machine setup. So I'm gonna, if you wouldn't mind stopping the screen share.
Yeah, and obviously we'll make the rest of those slides available, and all those slides available to you guys as well.
Great.
For further information.
Cool. So I'm going to go ahead and switch over to software here. Okay, everyone should be able to see Bantam Tools software. And if we could just put the camera in on the machine, awesome. Everybody good? If we see, Graham, can you see the software here? Can you just give me all the technical? Okay, great. So the first thing that I want to just kind of, I know we don't have a ton of time left, so I just want to hit home a couple points here. The Bantam Tools milling machine software has a couple different kinds of work offsets. And the most important thing to remember is that in the Bantam Tools software, you set both the position of the material in the machine and you set the position of the plan in the machine. The material is relative to the top left surface of the machine bed right here. And then the plan is relative to the top left surface of your material, which is why before when Graham was doing that facing pass early on, I said, hey, can you set your work coordinate system to this top left edge? And you'll see why in a moment. So let me switch back over to software for a second. First thing that I'm going to do is I'm going to open up the first facing and adaptive pass. And I can switch on the preview. Let's go to preview toolpath. Right, I need to select the tool. So we programmed this with a 1/4 inch end mill. So now there's my preview. However, this is in sort of like a random spot in the machine. So the first thing that I'm going to do now is probe for the material placement. So I'm going to jump down here to material. I've already input the X and Y dimensions of that material that Graham used in the setup, but now I need to grab its placement. So I'm going to open up automatic stock probing. This tells me, hey, make sure that your material is conductive, and I'm going to jog the probe into place. And let me switch over to the machine here for this part so you can see this. I'll bring the Z down, jog this over this edge, and then I'm going to hit start. And so before I did this demo, I inserted this 1/4 inch probe. It's going to touch off the top, it'll slide over, it will touch off the left side of the material, and then it's going to touch off the front of the material. And because we've aligned our work coordinate system for this op1 along that top left edge of the material, I don't need to adjust the plan placement, right? Because that's the default location for plans in Bantam Tools milling machine software. And just looking at the comments here, Caesar says, what would happen if you selected the incorrect tool in the Bantam Tools, like a smaller tool? So this is a great question. Probing actually works with any tool that you have inserted. It's going to look at the geometry of the tool. And so when you do your tool touch off to begin with, you want to make sure that you're inserting the correct tool. Otherwise, you will get some wonky measurements here. So the probing finished, and it says that the X offset is 1.627 inches, the Y, so on and so forth, 3.7. And let me jump back over so we can see that. And it's asking me to accept these changes. So I can click accept. I already probed before, so this isn't moving a ton. But now this plan is ready to go. So this would have been what Graham did, programmed for the facing and just that first roughing pass. So what happens when you want to adjust the plan separate from the material? Well, this part is really great for that because it's sort of done in 3 operations. And Jim says, when you install the probing tool, do you have to bottom it out, or can you eyeball it and the machine will sense it? So when you install the probing tool, it touches off the front left edge of the material, of the machine bed, excuse me. Let me just go ahead and show that quick because I think that will also hit home this point. So this is the install tool procedure. You would select the probe, just so people are absolutely clear what's going on here. It moves over to this front surface of the front right, edge of the bed, and then goes down and touches off. So Jim, hopefully this is going to clarify your question. This is what would have happened. This is what I did before we started this. So I showed the operation 1. The next thing that I'm going to show is sort of the operation 2 setup. So for Graham's part and for this knotting tool, what we're doing is we're machining the first part, then we're going to take it out, we'd flip it back over, and we would want to face off this hat here that would be left. So let me go ahead and open that file, facing up to go ahead and select the 1/4 inch end mill for that. Now we're seeing a little bit different of a thing. Let me go ahead and hide this first facing. And so to set up this op, I would do the exact same thing that I did before, because in Fusion, if I switch over here for op 2, we are still aligning with this top left surface. So I would go through the same automatic stock location routine, setting that up where I would go to my material setup, I would go to material placement, and I would probe the material. But the interesting one is when we're at op 3. So here in op 3, we've got this scallop pass. And I'll link to the video where we really go through all the machining of this in a little bit. But for op 3, the WCS now is aligning to this model box point. And that's set up. Graham, jump in where I'm going to be butchering the fusion explanation here. But that is set up here as the model box point, and I've chosen this back left edge. So let me jump back over to the Bantam Tools software. So this would be sort of the op 3 setup now. I would hide this as well, open this last file, this scallop pass, and now we're going to see something sort of interesting happen here. Where, turn on preview in Toolpath, where my toolpath is kind of hanging out here. So what's going on? Well, the WCS for this one, remember, go back here. WCS for this last one, remember, is on this back corner. So what I need to do is now I need to probe that same edge. So for this, what I would do is I'd open up this plan placement routine, and I'd probe. And we have a bunch of different routines. We've got some sort of fancier ones under this, under our software subscription, and we've got this sort of Swiss Army knife probing routines of this single axis conductive probing. So I'll launch this one. And here I can probe each axis individually. So I'm going to click next. I'm going to jog my spindle into place again. For this, I would touch off in Z first. So I'd go probe Z. And then I'd hit set Z0. Then I'd come back up. I'd go along this back edge, move this into place, come down. And now I want to probe that back edge. So here, I would hit probe Y negative. And now the machine is coming in along that back edge. And here now, if we look sort of in the preview, when I hit set Y0, now the preview updated along that back surface. I will come off that back edge, jog the spindle up, Sorry, I'm doing a video switcher while also grabbing the jog wheel of the machine, so this is fun. Let me come down, and then now, last thing. Oh, go ahead, Graham.
Well, I was going to say, even though you're doing all the switching, I think it's awesome you can do all this from your computer. I think as a camera user, I think it looks really, really cool. I think it's such a great ability to be able to do that. It's fascinating.
Oh, cool. And then the last one, I'd probe the left side, hit set X0, close that out. Okay, and now for that final scallop pass, now this boundary is set correctly, and it matches what I have in Fusion. So hopefully this gives you a little bit of a sense of, jump back over here, of how you would set these different work offsets in the Bantam Tools software and sort of configure your specific file that you're creating in Fusion. Maybe we should bring this camera back up so I can actually see people for a second. I'm up and ghost behind the machine. And jump back over to Webinar Jam. You just check in on the questions here. Wondering, since you set the tool in Fusion, wouldn't Bantam know to use the same tool, or at least filter to the same type of tools that are requested? Not actually sure I understand that one, but I'll hang on after this to read through that. Caesar says, if I have a larger fixture plate that is the size of the machine table, would it be a problem during a probing routine? No, as far as all of the probing is concerned, the only thing with having a larger fixture plate than the machine bed would be how much it's overhanging, and would you get any collisions when the bed rapids into place, Caesar, but happy to troubleshoot that with you. Michael says, why wouldn't the G code or NC code set the tools in Bantam? Why would you need to select it? Okay, Michael, this is a great question. I'm so glad that you asked that. Let me show you why. Part of the reason that you're selecting these files here is so that we can generate this preview for people. So what's important to remember in the Bantam Tools software is, let me close this out, and this isn't as good of one to show, this one instead. When you load a G-code file in the Bantam Tools software, the speeds and feeds for that file are going to be taken directly from whatever you programmed in Fusion. And you're just streaming G-code to the machine, right? But the preview is going to give you this nice visualization to say, hey, if you're using a 1/4-inch tool, let's say you're not looking at the preview visualization in Fusion. This is a secondary way for you to have a visual idea of, this is how much stock I have in the machine, I've measured it, this is what I'm telling the machine that the size of the stock is, and this is what the tool is that I'm going to be using. Now, it's not going to grab the speeds and feeds from whatever you choose from this dropdown, but let's say I chose to mill this with the 1/16. Whoa, what's going on there? Well, that's because the toolpaths in Fusion are stepping over based on the 1/4-inch tool. They're not stepping over based on the 1/16-inch tool. So hopefully that helps answer the question.
Zach, yeah. I think you might be a bit zoomed in. I think not everyone can see the whole screen.
Oh, shoot. Are we having the same issue now?
Yeah, I think we might be having the same issue.
Oh, I know what it is. Hold on. Let me come back here. Jump over to this. Is this better for everybody?
Okay, yeah.
Cool. So let me just show that once more. So again, the tool that you select from this dropdown here is really just for the preview to the end user. So if I chose a 1/8-inch tool, I'm going to get a different visualization. If I chose, I think before I chose a 1/64 tool, right? This is kind of garbage, right? So this is why we have the visualization here. Additionally, if you're running like an SVG file, in that case, then our tool library is going to come into play. And that's where the speeds and feeds are going to be pulled from the Bantam Tools software because the CAM is being generated directly in the Bantam Tools control software. So for G-code, again, the tool dropdown here is really to provide a visualization. The speeds and feeds are going to come from Fusion. So hopefully that clarifies things. And I think that just looking at these, I think that I'm gonna hang out in chat and answer some of these questions. But for everybody else, since we're like well over an hour, I think that we should probably wrap. Graham, I can't thank you enough for dropping all this knowledge on us. This has been great. Oh, you're muted again.
Yeah, I was going to say happy to help, and yeah, it's been a great session. So yeah, perfect.
And we'll put the recording of today's stream up on our blog, and we'll also Graham's been kind enough to pull together all of his slides, so we'll post those on our blog as well. We'll send out an email to everybody who signed up today and share those with you. So yeah, hopefully you learned something and got some of your questions answered. Stay safe, everyone. Graham, great to see you again.
You too, man, and yeah, have a good rest of your day.